Welcome back to Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today, we're wrapping up Chapter 2 on operating system structures with a comprehensive summary. Sheila, are you ready to dive in?
Absolutely, Victor. This chapter has been a roller coaster ride through the intricate world of operating systems. Let's break it down for our listeners and highlight the key concepts they should take away.
Great idea. Let's start with the fundamental services that operating systems provide. Can you give us a quick overview, Sheila?
Certainly. Operating systems offer a wide range of services, Victor. Think of them as the ultimate personal assistant for your computer. They manage programs, allocate resources, handle input-output operations, and provide a file system for data storage. It's like having a super efficient office manager for your digital workspace.
That's a great analogy. And speaking of workspaces, let's talk about how users interact with this digital office manager. We covered two primary interfaces in this chapter, right?
Exactly, Victor. We have the command line interface, CLI, and the graphical user interface, GUI. The CLI is like talking to your assistant through a walkie-talkie, text-based, precise, and powerful for those who know the commands. On the other hand, the GUI is more like a visual dashboard with icons and windows that you can interact with using a mouse or touchscreen.
Perfect explanation, Sheila. Now, let's delve a bit deeper into how programs actually communicate with the operating system. This is where system calls come into play, right?
Absolutely, Victor. System calls are the bridge between user programs and the operating system's services. Imagine them as the official request forms that programs fill out to ask the OS for specific actions. We discussed various types of system calls, including process control, file management, device management, information maintenance, and communication.
That's a crucial concept for our listeners to grasp. Now, we also talked about system programs, which are different from application programs. Can you elaborate on that, Sheila?
Of course. System programs are like the specialized tools in our digital office. They provide a convenient environment for program development and execution. This includes file managers, status information utilities, programming language support, and communication programs. Think of them as the Swiss Army knife of the operating system, always ready to help with various tasks.
Excellent. Now let's shift gears and talk about the design and implementation of operating systems. This is where things get really interesting, isn't it?
Indeed, Victor. Designing an operating system is like architecting a city. You need to consider various goals and mechanisms. Goals might include efficiency, reliability, and flexibility, similar to how a city planner thinks about transportation, safety, and adaptability. The implementation involves careful coding, usually in a mix of high-level languages like C or C++ for most of the system, and assembly language for the parts that need direct hardware manipulation.
That's a fantastic comparison, Sheila. And just like cities have different layouts, operating systems have different structures. Can you remind our listeners about the main types we discussed?
Certainly. We covered several structures, but the main ones are monolithic, layered, microkernel, and modular. A monolithic structure is like a big single-piece machine, efficient but hard to modify. A layered structure is more like a stack of specialized departments, each with its own role. The microkernel approach is like having a small, essential core with most services running as separate processes. Finally, the modular approach, which many modern operating systems use, is like having a core set of components with the ability to add or remove modules as needed.
Excellent summary, Sheila. Now, we can't forget about the importance of debugging and generating operating systems. These processes are crucial for maintaining and customizing the OS, right?
Absolutely, Victor. Debugging an operating system is like being a detective in a complex digital city. You need specialized tools and techniques to track down issues without disrupting the entire system. As for generation, it's similar to customizing a car. The process allows system administrators to create a custom operating system tailored to specific hardware and user needs.
Great analogies, Sheila. Finally, let's talk about the system boot process. This is how the computer comes to life, isn't it?
Exactly, Victor. The boot process is like waking up a sleeping giant, It starts with a bootstrap program, usually stored in ROM or EEPROM. This program locates the operating system kernel, loads it into memory, and starts its execution. It's a carefully choreographed sequence that brings all the components of the computer system online and ready for use.
Fantastic explanation, Sheila. As we wrap up this chapter, what would you say are the key takeaways for our listeners, especially if they're preparing for an interview?
Great question, Victor. I'd say the most crucial points to remember are 1. Understanding the various services an operating system provides. 2. Knowing the difference between CLI and GUI 3. Grasping the concept and types of system calls. 4. Understanding the role of system programs. 5. Being familiar with different OS structures like monolithic, layered, microkernel, and modular. 6. Having a basic understanding of OS debugging, generation, and the boot process. These concepts form the foundation of how operating systems are structured and function, which is essential knowledge for anyone in the field of computer science or software engineering.
Excellent summary, Sheila. And that brings us to the end of our episode and Chapter 2. Thank you all for listening to Operating Systems Crashcast. Stay tuned for our next episode where we'll be diving into the exciting world of process management.